Nowadays, we gotta stay indoors all day. But when we were able to go outside, have you ever wondered, why does the weather change from day to day? The answer to this is called meteorology. Meteorology is the study of what's happening in the atmosphere and predicting the weather. Meteorologists study air masses to understand how different weather forms. An air mass is a body of air in the lower atmosphere that has the same temperature and humidity throughout the whole thing. These air masses can be really huge in width and in height. The temperature and humidity is going to depend on the place where the air masses originated or started, and it's going to take it along as it travels. The humidity depends on whether the air mass started over land or water. This is called continental or maritime, and the symbol is a lowercase c or a lowercase m. The temperature is going to depend whether the air mass started in a cold place or a warm place, called polar, near the North or South Pole, or tropical, near the equator, and the symbol is a capital P or T. Let's discuss air masses that occur in North America. The first is Continental Polar, which originates on land. Continental, for example, Alaska or Canada, and is usually cold since it's near the North Pole. This type of air mass will give us really sunny but cold winter days. The next one is Maritime Polar, which originates over oceans in the high latitudes near the North or South Pole. Remember, when it's wet, it's not going to be as cold as if it was dry air because land gets colder than the oceans. When this air is going to be cooled down to its dew point, the water in the air is going to form clouds and eventually precipitation. For example, occasionally maritime polar air masses from the North Atlantic are going to bring in snowstorms called northeasters to New York City. The next one is called Maritime Tropical. This originates over warm water and it becomes both warm and moist. This can create thunderclouds, which we'll discuss in the next lesson. The next one is Continental Tropical. This one is over land, so it's going to be dry, and tropical, meaning it's hot. This can originate over deserts, but very often it's maritime tropical, wet, warm air that lost the water because it all rained out. Now this air is dry and hot. Without the water in the air to cool it, this air gets way hotter than maritime tropical and is sometimes known as a heat wave. So how does this affect our weather? The answer begins with fronts. A front is a boundary between the air masses, and there are different types. The first is called a cold front, which is represented by these triangles on the same side of a line. A cold front is the boundary when cold air slides underneath warm air and pushes it upwards, since the air masses don't mix. As you can see, the warm air is sitting there and the cold air begins to push the warm air up. The moisture in the air begins to rise, condense, and form into clouds. These clouds are going to be a lot taller, as well as you can see the wedge shape of the cold front is going to be very tall as well. When dry cold air displaces wet warm air, thunderstorms will form because the moisture in the air is pushed up and forced to condense. When dry cold air displaces dry warm air, there's no water in the air for precipitation to occur, and the only thing that will happen is a change in wind direction. The next type of front is called a warm front, which is represented by these half circles on the line. A warm front is a boundary when warm air rises above cold air, making it move away. The cold air is just sitting there, and the warm air goes on top and begins to slowly push it. The warm air is going to push the cold air slower because it is not as dense and not pushing it as fast. What's going to form on top are flat layer clouds because there's not enough air for it to form higher. Look at the blue line from A to B that's going through two different fronts, a cold front and a warm front. The first thing you'll notice on the cold front cross section is that dry cold air is pushing warm wet air away. The cold front is a lot higher than the warm front, and the clouds that are going to form are also very tall and will have thunderclouds or precipitation. As opposed to the other side, on the warm front, the warm wet air is going to be pushing cold dry air away. The front itself is going to be a lot shorter, as well as the clouds are going to be layer clouds and not tall. You can see this in questions like these where they show you different cross sections. The first thing is that the warm front is a lot shorter than the cold front, as well as the warm air is going to have flat stratus clouds, as opposed to the cold front is going to have tall cumulus clouds. Take a look at some of the other answers. You will see that there are other fronts besides cold and warm. The other one is occluded, which is represented by triangle and half circle on the same side, and that is when warm air is caught between two cold fronts and is forced to rise. This is because cold air moves faster. As you can see, cold air is just sitting there and warm air on top, and then the cold air on the other side begins to push it, forcing the warm air up. And finally, the last type of front is a stationary front, represented by half circles on one side and triangles on the other. This is a front that is not moving forward at all and staying in one spot. As the warm air rises above, clouds and precipitation will occur. If it stays too long like this, this may cause flooding from continuous rain. Look at this weather map. The question asks us, what is the total number of different kinds of weather fronts shown on this weather map? At first glance, it may look like they're all the same, but take a closer look. First, we have the cold front over here. We have the warm front over here. This is a stationary front, and this one is an occluded front. So in answer to this question, there are 4 different fronts on this weather map. So now we can begin to understand how it affects the weather. An area that gets lower pressure in the center usually starts when cold air meets warm air and will grow into an intense storm system. About 100 years ago, Norwegian meteorologists developed a theory explaining the cycle called upper airflow. The most important thing to remember is that the air is not two-dimensional, as you see on the map here, moving back and forth, but is actually three-dimensional, going up and down as well. The air that's flowing higher up is called upper airflow, and is what controls the path and intensity of the low pressure system. Upper airflow is usually curved, and as air approaches the curve, it converges or gets really close together and tight, kind of like a traffic jam. So some of the air is going to detour and sink down, creating higher pressure. As it sinks, it puts more pressure on the surface on the ground. We know that air will go from a high pressure, where it's really close together, to a low pressure, where it can spread out. As air goes from a high to a low pressure, it begins to rise back up, since there's nothing pushing it back down. The air is going to rise already past the curve in the upper airflow. So the weather that you experience is going to depend on where in the pressure system you are. In a lower pressure system, as warm air approaches, layer clouds are going to form, followed by steady precipitation and a drizzle. As it passes, if the air is dry and there's no more moisture, the sky is going to clear up. In a high pressure system, you'll have fair weather, since high pressure means air is sinking and no water is rising up into the air to create clouds. This is going to give us a clear sky with little or no winds in the center of the high. Because the highs aren't moving, it usually takes on the temperature and humidity of the area. Highs are usually where the air masses form, as opposed to lows are usually surrounded by 2 or more air masses and are going to move and take the temperature with it. That's all you need for today. Tomorrow we're going to discuss thunderstorms, tornadoes, and hurricanes, and other types of weather forecasting. Thanks so much for watching. Make sure to answer the questions in the forum and hit that submit button. Have a great day.